Hello and welcome back. This part 3, covers the assembly of the capacitor arrays into 3 separate Dynamite Stick tubes. Except for soldering iron burns, 2 of them on the same finger, it is relatively non-hazardous, but may bore some quickly. Watch at your own risk. After much measuring and adjusting, I ended up making 3 different orders from DigiKey for capacitors to get values that would add up to what I want to put in the substitution box in order for them to just generate a value that was going along with the markings in the box. Granted, the tester I'm using is not a laboratory grade piece of measuring equipment, but it's one of the few that I have that is specifically designed just to test capacitance, so I am going to presume that it's got about the best potential for getting an accurate reading. I also have to take into account that none of these capacitors have been really formed over time per se by having a voltage on them. They might drift in value towards a higher value if they do actually get and store a rated voltage on them for a while, but in this case this box is not going to be in that condition. It's going to be mostly discharged and not used too often, but I just want something that has something close to its marked value to begin with. So I'm going to go over the combinations that the box is calling for and the capacitors that I had made up. One issue I did find is these are all Rubicon brand capacitors. They're all various models. Some of them are, this one for example is an MHX model. They're all 180 volt rated, and to get a 350 microfarad value I had to combine 3 different capacitors, 2 180. I was hoping that 2 180s would get me a 360, and that was not the case. What happened was 2 180s in parallel of this particular model got me, oh come on, I know I can get a continuity here. Darn it, not having a good day. Got me a 317 only, and then I found that I had to add a 39 microfarad at 450 with this tester, and then that did get me right to a 350. Fudging around here. This will get easier because this is one of the harder ones to get all the connections in. Repeatable results are what we want here, but I'm having a hard time even getting it to happen once. There's a 317. Oh, man. Well, anyways, I measured a 350, but if you notice the capacitors by themselves, this one was a marked 180, and it's only measuring 160 on this capacitance meter. That is, it's within the 20% tolerance, but it is on the low side. It's disturbingly low. The other one is about the same, 159, 158. The 39 microfarad that I'm using to make up the balance measures out at a 36, which is pretty close. But anyways, that's my 350 value. And next one I need is a value of 225, so I get a 220 here. 220 measures out to 185, which is on the low side, but like right at the 20% line. and adding another capacitor gets me to 217, which is fairly close. This one is a 33 microfarad. This is a LXW model. These larger ones are MXGs. They all have a 105 degree rating, temperature rating, and anywhere from 1500 to above 2000 hours. Third selection is a 150. I did purchase a 150. This is a VXH model. And this 150 on this meter measures out to 123. And then I'm adding a parallel capacitor of 33 to get me to 151, 152. Trying to get these within the value factor of 5% at least, if not better. My 100 microfarad, I ordered a 100 at 450 model MXG. These are all sourced from DigiKey, so they're all none of them should be counterfeit. They're all from a reputable supplier. 99.66 by adding a 15 microfarad LLE model. These are supposed to add up to a value of 80. I was originally planning to use 239s, finding that 139 by itself was measuring down to 36.3. This is the 39, and what I did is I ended up adding a 56 to that. These are both model LWX. And with a 56, that's got me very close. I mean, very, if not spot on to 80. I mean, within 1/100th of a microfarad according to that meter. So that's a pretty good match there. These two are supposed to be up at 60. I was hoping to be able to do this with only one capacitor as well, but that wasn't the case. Even a 68 would have been nice, but I ended up using a 39 LWX and bridging a 33 to that, which gives me a 61. Got a 40 microfarad value. Seems like the smaller ones are actually closest to value. .40 measures out to 37.6. I'm not going to sweat that. That's basically almost within 5%. 20, that was a 22 microfarad, measures out at 21.8, which is acceptable for sure. This one is a 10 microfarad model PK. 9.74, which is good. And this is a 4.7, which measures out to 4450 nanos, so that's 4.4 micros, which is a good value. So the only thing about these is, like I said, they're a mismatched bunch. You probably wouldn't want to parallel different models if you're going to leave them in a circuit, but considering this is just for short-term testing on a device to make one part of a circuit work, I'm not going to sweat it. It's not worth worrying about. So after this, we are going to work on actually putting these into homemade Dynamite Stick capacitor bodies and doing the wiring and starting to restore the box. In trying to get these capacitors into 3 respective tubes, I'm going to build them into 3 groups. We're going to put one group into a skinny tube here, the 4, 10, 20, and 40. From the looks of things, I'm going to I've got a large group that's going to be the 350 here, and I'm probably going to take, I've got to make a 3-3-3 configuration here, so I'll probably take this, and this. This will be the 100, 350, and the 150 in this group. And then this group will give me a 225, 100, 160. And that should leave me ample spacing within each tube. This one is, the bigger ones are going to fit in the 1.5-inch tube. It should be able to get all three of these sets in each one of these tubes without much of a problem. These will fit side by side even. Yeah, that's a little tight. That'll go, okay. I'll fit side by side. These I'll have to orient so they go end to end, but everybody else will fit side by side and should have space for everything and everybody, with the just doing a little insulating and creative soldering for the leads. I'm going to go over this construction with the preface that this is not the only way to do it. I am sure that other people might come up with a different method of making an enclosure tubing for the capacitors. You might use different materials, plastic, metal if you wanted to, even some aluminum tubing, all sorts of different ways to do things. I chose to use some plexiglass that I made for end discs for these. That can be done with cardboard, metal washers, all sorts of ways to do this stuff. So the whole premise was just to get something to have a desired effect to contain the capacitors in a way that looked reasonably stock and didn't let them rattle around loose inside the box, and could be taken out of the box in case you needed to access the switch in a group without having to desolder terminal strips and all sorts of other things. What I'm going to do for connecting the capacitors is that for the smaller values, I'm going to just use some 20 gauge silicone stranded wire. It's not going to be a high power, high current to charge up these smaller ones, so I'm going to use 4 colors and a common. And then what I did is I made up some little crimps out of some brass tubing. I'm going to secure the connections inside, that will be inside the tubing as I go along with this brass tubing, solder it, because it's very hard to twist and then solder connections, especially when you're going from solid to stranded wire. I don't like tack soldering wires onto metal or other devices. I don't think that's a good way of connecting things. A lot of times you're going to have a crystallized solder joint that might either make a bad connection or pull apart later on. And if it's enclosed inside the device, it might cause a malfunction to the point where you have to tear everything apart and remanufacture it. If I take some of this crimp tubing, put some soldering flux paste inside of it, crimp my connections together with a little squeeze, and then flow some solder onto it, it should have a fine mechanical and electrical connection without having to worry about things coming apart. I managed to find some tubing that was different sizes. In this case, for the smaller wire connections, the interior of the tubing is approximately 0.71 inches, or about 2 millimeters. You can see that. It's about a 2 millimeter inside dimension. I have a larger piece of tubing that I'm going to use for the larger gauge wire, larger capacitors. This one measures out to about a 2.5 interior diameter, and you're probably wondering why I have those brad nails in there, and I shall show you why. I was trying to figure out a good way to cut this tubing. I tried using a little pipe tubing cutter, and even the smallest one I could find didn't have a diameter small enough that would really cut this tubing well. It actually wouldn't ride on the rollers. I can get to the cutter blade, but it would be on the just on the portion of the cutter that didn't have a roller blade, and it wasn't quite working out well. And what I discovered was that just by taking a good pair of some sort of cutters that have these particular wire cutter strippers have some good cutting jaws in them that are more than capable of cutting through this brass. And what I've done is I've just measured out to inserted a nail in there that fit in the tubing, and I'd measure out to a point where I'd like to have the length cut, and then just take it and even just rotate it slowly and squeeze it, squeeze it, squeeze it, squeeze it, squeeze it, squeeze it. And I can get to the point where you make a nice crimped notch in there, and then you can take your nail and break it right at the notch. Very easy to do, and I made a assortment of these for the 2mm tubing. I'll have to do some more for the 2.5 as well, but just an easy way to make little crimps. I mean, you can probably even manufacture these into rivets if you had a punch and a backer block to block it up to as well. So it's but just being able to cut this tubing as easily as this is nice. It's just a quick method of doing something like that. And now I'm going to try to get to the actual crimping things together. I've got my tube here. I'm going to end up stuffing this with some polyester filling. I'm going to hot glue a base onto it, and then the top I've got to make some cuts in here. What I did on the bottom is I just made some cuts with some scissors and bent them all over. I'll bend them over well, put some hot melt glue in there, put a bottom in it, and then I can put some polyester fill in there. But the main thing is I have to manufacture these 4 capacitors in a way where they will all fit in this tubing fairly comfortably, height wise, which it looks like it shouldn't be a problem. And just start off with the 4 micro first. I plan to use the green wire for that. I'm going to make my wire probably a good 12 inches long on that. I don't want to short myself. Let's make it 13. I'll make it 12. I can go progressively shorter as I go inside the capacitor, but I want to make sure I have enough where I can pull the whole assembly out of the box. Maybe on this one I can probably go about 10. Let me think that out. Got a measuring tape on the bottom of here. Just something where I can take it out of the box and flip it up out of the way. So to go from 13 to 3 would be 10 inches. That's going to be the top capacitor. That should give me enough slack. I'll go progressively longer as I go further into the capacitor. And this is 20 gauge, so this is going to be probably get these all into configuration and then solder them. A little rosin flux inside the connector should be more than ample. I can probably do too, as there's no specifications on this as far as wire gauge or anything. I'll probably, in order to get a little more mechanical, oh, there you go. In order to get a little more fill inside that guy, I'll end up bending them over 180 degrees so I can double them up. Let's put a hook on it and smash it flat. There. would like to get all the strands in there though. And as far as crimping, anything goes with this. Just about any pair of pliers you'd want to use, I'd imagine, would be acceptable. Just to give it a good mechanical crimp. That way, it won't be flailing around. And then for the next, I could put some tubing over that, but I'm going to end up just putting some tape on it instead. The next connection, I'm going to go up to the next smallest capacitor. See, that one's going to be the one that's on top. So the next one's going to be the 10, which is this one here. Give it a little space between them. Okay. And that one is approximately going to be about another inch down from there, so I'll make the next one a blue wire, and it's going to, the blue wire are going to make 11 inches long. See, I made this one 10 inches long. I'm going to make the blue 11. So from 13 to 3 to 13 to 2. It's the positive again. A little more flux for the brush. I could get some heat shrink in the mix. We'll see how things happen after I solder all these. The next one would be the 22 microfarad. So hook the lead again. 2220, we're going to go with a white wire on that. That one we shall make 12 inches long. And our last capacitor that is left is our 3940. So keeping with the scheme of things, we're going to go another inch longer on the wire there. Red wire. Get a good amount of flux on there, just to make sure it cleans everything up as we solder. A little big. I'll tighten him up a little bit. Okay. That hard wire is taking up so much space in here. I'm having a hard time getting the stranded in without splitting the braids, but I think I got it. Okay. Okay, that gives me 4 good mechanical connections, and at this point there's no reason why I can't get a small piece of heat shrink and put them on all these, just to, after I solder it, just to make sure that things are going well. So we'll set up a soldering iron, we'll show you how the soldering goes on them, and then I'll shrink them afterwards. And here is a blast from the past that people probably haven't seen in quite a while. It's an old Heathkit GH17A soldering station. I know the lineage on this because my oldest brother built it back in the late 60s when he was getting into doing kits from Heathkit. He did a Dynamite amplifier and preamp. He did a Fisher tuner and some other Heathkit items, and I'm hoping it's still serviceable. It's the only fault I found is its old 3-wire cord has a crack in the insulation in one spot right by my finger there. You can probably see it pretty good. It's it's going to need to be replaced sometime soon, but other than that, it should be a serviceable soldering iron. And this has one really nice feature about it. You've got a spot in the back of the unit that holds the tip of the iron. And what it also lets you do is it lets you take the iron and seat it in that metal cradle, and it allows you to do hands-free soldering on a tip that's fairly secure and won't rattle around too much, hopefully, if things work well. It's better than trying to work something else out half the time, but it's kind of a nice feature. Not too many soldering stations will let you do something like that, so it'll come in handy in this instance because I can handle the capacitor and the feeding solder to it at the same time and not worry about having any mishaps. Okay, I found some heat shrink I needed. I've got the tip set up here, and throw a little hot solder onto it, and just use the pair of long nose pliers as a heat sink to make sure the capacitor doesn't get heated up on a lead, and that should give a good connection. A lot more secure than trying to tack solder it. So we'll just continue with the other three. The process of soldering is kind of remarkable in a way, because you can, once the solder is heated up, it'll actually wick inside of a connector. That one looks like it got a good connection out of the deal. And I'll have to repeat this process with the ground wire network on these, the return common network as well. I'll just have to use short pieces of black wire in between capacitor to capacitor, and then have the final lead a longer length. So, not really worried about getting solder on the outside of the connector as much as on the inside, although I should get rid of that little spike on it. That won't be the best for putting a heat shrink on it. There we go, flatten that out good. Not really, like I said, not concerned about getting solder totally on the outside of the connector. It's what's inside that counts. So, as long as it's a secure mechanical connection, it's a lot less likely to form crystals when it cools. And with all that paste flux that I put in there, it will have a good affinity to be clean on the inside of the connector and draw solder in. Nope, got the spike again. You can usually tell you've done well when you filled up the end of the connector, which I've done. So no voids, a good connection, and should be good to go. So I'm going to continue building the ground portion of that. I'm going to insulate these first, build the ground portion of it. The ground leads I won't be able to insulate, so I have some Kapton tape. It's a high heat insulating tape I can put over it. That will help to insulate that, just in case there's any mishaps. But other than that, we've got a good start at getting some connections going on inside of a tube. And I'll just go over making the last connection on the return. I'm going to kind of made these capacitors in a staggered configuration, but what happens is they'll fold back onto themselves. The soldering iron's hot. Ow, damn, twice. Soldering iron's in the way. They'll fold back onto themselves, and I'll put some tape on top of the vents there, just to make sure if they blow, they blow. Nobody really cares, but I'll fit into the tube that way. And I'll go over making the last connection here. I've got one more little piece of brass tubing to use as a connector crimp. The larger capacitors are going to be a lot more elaborate to get into configuration in those tubes, just because they have multiple values to bridge together along with making the connections for the individual values. So I've got some flux in both of those. I have my last capacitor here. My 10 micro, it's going to be on top of the bunch, the shortest lead. I'm finding myself using the 2.5 millimeter brass tubing because I have 2 wires going into each crimp, so I've got them. You can see the way I've got it configured. Put a little flux on the wiring too. Okay, I got that. Stranded wire always has a tendency for a strand to want to escape unless you tin it beforehand. It's just the way it is. Oop, so we had another one there. Oh boy. This is a test in patience. I tried tinning them beforehand, but the problem was that ended up balling up so much solder on them that they ended up getting to be a fairly large size in diameter, and I was having difficulty getting all the wires in there. Okay, we got those guys in there finally without any stray strands. It's going to give it a squeeze with some pliers. Got a little solder on the tip to get things going for the heat transfer, and a good amount of solder wicked into the brass ferrule as well as onto the wires. So we're going to, I'll end up testing these before I install all of them, of course, and then I need to put some tape on them. But we're going to, the next step is to insulate everything, and then to start to populate the tubing I'm going to use to make the do-it-yourself dynamite stick. So they're going to go basically and look like this with some insulating tape on all the commons. Just as a quick check here, I ended up populating this, and it looks like it's going to work out okay. I got some space for the wiring up on top there, and capacitors on the bottom. I'm going to put an end cap on there still, but we'll get into that in a little bit. And then we have our wiring length, which is all about Looks to be about 8 inches long, all about the same length. Get a little ruler under here. Up. The return is 9, and the other leads are just a touch longer, but it looks like something that was manufactured kind of correctly. So I'll probably end up pulling up a little closer to the end of the cap as well, just to give it a little more length. I've got to stuff some polyester fill in there as I go, and I'll probably go over doing that with you in a minute. And I thought I'd share some manufacturing with you on one of the Dynamite Stick arrays here. I've got 2 values set up here. This is the 350. This one is, I forgot which one. I'll have to measure it. But anyways, I'm finding that vertically it was challenging to get something to go into space vertically. And these, I ended up having to put the smaller value in with the bottom on here, and then it would fit in the 3.5 inch diameter tube without an issue. So, the bigger ones I have 3 and 3. The smaller one I've done already. This one has the 4 smallest capacitors in it, and I just sealed up the ends with some hot melt glue, and made sure it was a small enough length to put a little cap over the end of this one here. It didn't really have to, but I did it anyways, just to see as an option. So I'm going to mark these with a label maker, P-Touch label maker, for the values, type of capacitor, and the voltages in there, so there's no confusion in the future if somebody does go in there and wonder what's going on. And that's about it for as far as I've gotten, except, like I said, I was going to go over the some of the soldering here. This the smaller array here. If you see, I've got positive and negative bridged with the negative common here. A yellow wire on this one. This, and this are bridged all as part of the 350 assembly. I did manage to get some heat shrink on the little crimp fittings I put on for those snap-in leads, and everything's insulated either with the silicone wire insulation and or Kapton tape and or heat shrink. So it's looking like it'll be well protected in the future. So right now I am doing the negative comment on this one, and I have one of the crimp barrels. I'm going to put a little extra flux on everything, because I want this to have the ability to have the solder really flow in here. I'm going to take the end of this wire, strip it, flux it, and then I'm also going to grab a small piece of black heat shrink to slide over the wiring, so when I'm done with my crimping and soldering, I can slide the heat shrink down and cover everything up fairly well. So I probably want about that much black heat shrink. It's a little bit of a challenge to get this much wire in these pieces of brass tubing, but I've managed to do it so far. So this is one of those things, you don't do it every day. It's a total custom manufacture, so it's really pretty much a just a voyage of discovery as you're doing it. I said, it's not the easiest thing to get all the braids in the crimp, but we're working on it here. I got one of them in. If it's got a couple of strays, it's not going to be a big deal because it is going to have a piece of heat shrink put over the end of it. Not going to sweat a couple. If it's turns into a bunch, then it's an issue, but a couple is fine. Trying to get as much wire as I can in there, wiggle and jiggle and shake, and it looks like I've got enough as far as continuity there. So I'm going to take this pair of pliers and flatten this out. Gives a bit of a good mechanical connection there, so when I solder it, it will hopefully the solder will flow well inside the connector, and probably leave that up as a spacer. I'm not sure what the wattage is in this iron in the high setting, but it's a fairly good iron for light chassis work. I probably wouldn't think it would be enough heat to solder directly onto a chassis itself to solder a lug or something onto a chassis, but to solder wires onto most lugs, it looks like it would be an acceptable iron to do a lot of work with. Unfortunately, the heating elements are hard to find on those. So, looks like it's got a pretty good flow of solder in it. You usually tell because when you go to bend the wiring, some of it might actually wick into the braid underneath the insulation, and you can see where it bends, and that's pretty much where your solder stops. So some of it, as soon as solder in the rosin, it's pretty secure. So run a heat shrink down, and get the low budget heat shrink gun out. This works well enough for small pieces of heat shrink where we're not going to have to worry about firing up an actual electric one. This heat shrink has got some adhesive on the inside of it too, which is good because it helps seal everything up. Just got to make sure you heat it up enough. Okay, that's a negative side, and then start to work on the positive. So I can start bending these above the capacitor. You can see about a 1/4 inch or so. And then right about the center, of the two, after we get it horizontal, make it into a vertical lead, and I will do the same for the other side. I want to get them about even so I can, when I bend little hooks on them to help fill in the crimp a little bit. I said I'm not securing the wiring with these, but what I'm doing is making the brass tube get filled up with this wire a little more, just to give it a little more rigidity when it gets crimped onto. Oops. Also found that taking a pair of needle nose pliers and running them inside of here helps open things up. Makes it a little easier to work with. Little flux. Little flux on the wire. I'm going to slide this down below it for now. And my positive wire is going to, I've used red and yellow, probably use a blue. About 10 inches of blue. Oh no, I want to go a little longer. This is going to go on the bottom here. So I want to make it about as long as the black and the yellow. Looks like about right here. Doesn't have to be exact. It's going to be trimmed up when I go to solder it to the lugs on the switch. I found that sliding the wire in first when the brass tubing is past those two little hoops makes things a little easier, because then I can slide the tube up and everything gets into a good place. We've got a straggler. Try this one more time. I had one strand that was a escapee. Whoops, almost too far. Okay. Pretty good there, and I'm going to take now, granted, this isn't the most secure mechanical connection, but it does keep it from flopping around too much while you're soldering it. So. Okay. And a piece of red heat shrink. Looks like a good connection. And to get a little bit of rigidity here that's fairly well isolated as far as the leads, you can see they're spaced apart and not much of a chance of them shorting out by bending over, especially since this whole tubing assembly will keep them in a vertical position. I'm still going to add some Kapton tape to keep them positioned. So now I've got my the red I cut a little short. In fact, I mismeasured the red. Hopefully it'll make it where I need it to go. If not, I can piece it out. And it looks like from here I'm just going to put a little more Scotch tape on things. But that should give me a pretty good assembly for getting it in there. Oh boy. Oh. And put a little tape there. Found an old roll of tape, so I might as well use it up. The heat shrink is protruding on the connections here. That's going to be an issue. I'll do a little rework on that. We'll have to lay both of those down, and what I'll have to also do is put some fresh Kapton tape in between them. Maybe a couple of layers just to make sure that doesn't become a short circuit. I think we'll go 2 layers, even though the odds are low from that actually getting to be a short circuit. It's a good layer of insulation right there, but I'll go another layer of tape. The last thing you want is something that you are depending on as a tool to work on to fix other things that might not be functioning at the time. You don't want the items that you're trying to use to do that to turn into something that is not working as well. Well, it looks like there's a good air gap on everything. Okay. I think laying those down is a good solution, and that gives me enough room to put the cap on it. I can probably maybe even take this yellow wire. No, I don't want to mess with it too much. If I try to make some drastic bends in it, the crimp is right there, and it'll cause some problems. So it's in good part of my fingertip. And just out of curiosity's sake for performance, I should check this before I pack it and seal it up. So I'll knock a little insulation off the ends and put the capacitor tester in it. We're looking for a 350 value, I think should be the red. 352, 353. Blue is 60. And the yellow is 80. So we are looking good for that assembly. So I think by the time I get to the third one, I'll put in the video sealing that one up too as well. So I'd like to get along with the manufacturer and at least get these all these 3 made tonight. But I want to get some soldering done on the last 3 sets of capacitors, and then once I'm at the point where I get a little more practice with the second tube, which will hopefully look better than the first one, then the third tube will be even better. So I'll be back in a little bit and gluing the tubes together. I am just getting the last 3 capacitors in the last tube, and I had a real configuration conundrum with these. I had to make them so tight. The size was such a challenge to get them all in here that these are all, the large ones are all snap-ins, and I ended up having to bend the pins over and putting the crimps and wires on as flat as possible in order to get clearance on all these to get a size where these would fit in. And then I found out that leaving this lead facing outwards was not a good idea either, so I'm going to have to rework that one. That one's going to be a little bit of a challenge because it's got ground wire strung from the other capacitors, so I'm going to work on removing that right now if I can. Hopefully I didn't crimp it too tight where I can't pull it off after I heat it. take a minute here. They apparently made that pretty tight, and boy, the wire's getting hot too. Ooh. Might have to let my iron sit on high, get up to a higher temperature for a minute, so I'll be back in a minute. Okay, attempt number 2 at trying to get this crimp and solder joint loose. Clean my tip up a bit and hit the tip with some fresh solder. Try to get this where I've got a good view of pulling on the wire as I heat it up. Oh, good. Okay. Came off fairly easily. I think on high this is like 60 watts. I've got some slack in both of those I'm going to have to sacrifice in order to do what I want to do here. I'm just going to cut and re-strip. I learned something about wire cutters over the years. If using any type of wire cutters, the sides that have the deeply beveled edge as compared to the flat one, if you cut especially hard, I learned it from fish hooks mostly, but steel, copper, you have a little more velocity coming off the crimpers if you cut off of this way, the loose piece versus this way. It just doesn't seem to have as big a squeeze going off the one direction, so something to keep in mind if you're cutting things if you don't want your scraps to fly too far. What I want to do is have these wires come all out towards the middle of the capacitor, like the positive one. I'm going to route them so they're both coming in this direction in the crimp. A little piece of solder on the end of that one. And my terminating lead, I have to re-strip that as well. I think I'll just start with a fresh end on him. A little more flux on everybody. I think I'm going to cheat and get these two in the piece of tubing first. Try to cheat. Okay. Be a little bit of a challenge getting everything in from one direction, but it did fit last time. It looks like I am on near enough where it should take a solder. Looks to be a good joint. I didn't crimp it, but shouldn't matter. It's all in there securely, and I can add a small piece of black heat shrink to him. Then, if all goes well, that should fit a little easier into the top of that capacitor tube. It's my high-tech heat shrink coming in. That's about as low a vertical profile as I can get, and I think I can get those flat, a little flatter. So I'll let that tubing cool off. All I did on this guy is this particular one, since I needed the extra space, I just used another piece of the Nomex paper, cut a circle out, hot melt glued it onto the bottom. The top is going to get a plastic wafer with a hole that I have enlarged a little bit to get wires through. It's just the right diameter. It's challenging, but it's just the right diameter to get in. So, okay, I'm going to go for one more try at getting these as flat as possible. I didn't think that this height was going to be such a factor in this, but turns out it was. And I have a little piece of Nomex insulator in between each layer of capacitors, just to isolate them from each other to make sure there's no issues should arise after I close it up. Okay, that is tighter than I wanted. This is going to be a challenging one because I had probably an 1/8 inch of space to work with on the last one. The smallest one with the 4 small capacitors in there, that one actually had probably a good 1/4 inch of headroom. Oh, I'd be remiss if I didn't test these as well, so I better Better make sure they come up with a value if I glue this thing in here and make that mistake. Okay, we are looking at, not sure what it's supposed to be, but we'll find out. That's got to be the 100. Came up right at 99 very nicely. Yellow, I believe, is supposed to be a 225. 216 is what I got. Trying to get it closer would have required another order from DigiKey. I was not going to go there. And the 150 comes out to 152, so that's close enough, and it's definitely a lot better than what was in there when I first purchased this guy. Well, the only other thing is I'll probably take some, I've got some polyester fill just to kind of bulk out the sides of things here. I just have to make sure that I don't get much, if any, in between the capacitors, because I need that height. Side to side, I can stuff it in there, but top and bottom is a no-no. Grab a little more and stuff it along the outside edge. Got a little wooden poker stick. I'm not sure it's a good idea if somebody's making a do-it-yourself capacitor to pot them with some sort of epoxy or two-part filling material. It just seems to me that you would want the capacitors to have the ability to expand and contract a bit without being restricted by something else. The old ones, the old capacitors that were set up in aluminum cans, they were basically took up the whole volume of the can by the manufacturer. Just the way they were manufactured. From all the ones I've seen taken apart, and it's doesn't seem to make sense if you have capacitors that are meant to expand and contract a little bit, even though they're smaller in size, to try to restrict them to a container by potting them in an epoxy or something like that. This is just going to be a challenge. It looks like it'll go down enough, it's just that this disc is so close to the size of the paper. Part of the fun when I made these, I actually made the plastic discs by using a hole saw that was a 1/4 inch larger, and this was actually the scrap from the hole saw. Oh, I've got oh man, got a choice of doing two things. I can bevel the plastic edge on the inside a little bit, which I might do, or I could take the paper and make some cuts vertically in the paper and allow it to expand a little bit, but I think I'm going to go the route of cutting the bevel, or sanding a bevel on it a little bit, so I'll be back. Okay, I don't know how well you can see it, but I do have a slight little bevel sanded in this, so that should make a difference. Here, my hot glue gun heating up. It's been going for a while. There we go. This seems to get on there fairly well and popped right in, which is really nice. Doesn't necessarily want to stay in, but it popped right in. So I think what I'm going to do is go ahead and throw a quick bead of glue on the outer edge of this paper, or at least in a couple spots to hold it, and then try to press that disc down as far as I can, and then whatever is left for the possibility of adding glue to, I'll do that. I think I'm just going to hit 4 spots. Don't want to get too sloppy with it. Okay. Don't have a lot of working time with it. Try to press this down as far as I can get it. I'm just going to give that a minute and let it set up for a couple of minutes. It takes set times about 2 or 3 minutes till the stuff gets really sticky. Unless you add something to cool it off. So we'll come back to that. Okay, I managed to get a small bead of glue in all around the edge of that plastic wafer at the capacitor seam, and it's going to be trapped by the box anyway, so the only other thing I did was put some glue in where the wires are. Thought it was a good idea, but the one thing about hot melt glue is it really doesn't stick to silicone insulation at all. So anything silicone, it's not a long-term adhesive. So it's, and the size of this guy here, I just have to make sure that these wires are going to be as flat as possible coming off the side here. But we have the last one of the assemblies, all 3 tested well, so I'm going to take a break, and then tomorrow I'm going to start working on the actual reassembly of the box itself. Well, I have to mark these. I'll do that off camera. It's no big mystery. It should be marked somehow. And tomorrow hopefully will be a day of assembling and getting the box to work. This is what I'm gonna have, because I needed this clearance in the middle. Needed the vertical clearance. That's why you want such a small diameter of this guy. So that's it for now, and I'll get some more progress tomorrow. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.